So last little bit that we're going to learn for this unit before our test, and this is just something about how the periodic table is arranged and the scientists that were responsible for doing this. So Mendeleev was the first scientist that said, you know, I bet all of those elements that we know about, and there weren't that, we know about a lot more elements now than we did when he was around. But the elements that he knew about, he was able to arrange them into some sort of grouping, some sort of pattern that made sense to him. And he did this according to increasing atomic mass. Is that how our periodic table is arranged today, is by atomic mass? No, how do we arrange it? Atomic number. So going back to Mendeleev, he is known as the grandfather of the modern periodic table. He grouped it by atomic mass, and he even had some holes in there. I'm not sure exactly where these individual elements were, but he was able to do things like, let me look on the periodic table, number 32, for example, which I can't find very quickly on here. Number 32 for atomic, for atomic number, but remember he grouped this by mass, so that would be something like number 72, 73, somewhere in there. I'm not doing a very good job of finding this. Anyway, maybe it was right around in here. For example, germanium was not known at the time when he arranged all of these elements into a periodic table, but he was able to say something. He figured out that there were some common properties, some similar properties that these substances had based upon the way that he arranged it. So he was able to look at this and say, you know, I bet there's an element out there that just hasn't been discovered yet, and it's going to have these types of properties. And sure enough, something like germanium, for example, was discovered. So he arranged according to atomic mass. Then a little bit later on, Moseley comes along and he fixed things. He's considered the father of the modern periodic table. So instead of just arranging it by mass, which works most of the time, but not all the time, what he did was he arranged it according to increasing atomic number. And it was quite a shame because he was a young man and he did pass away pretty early because he served in the war and got killed that way. Okay, this is a quick lesson, by the way, that for those at home, we're running out of time. But so we can break the periodic table up into metals and nonmetals. If you were to see how this, on lots of periodic tables, you'll see a zigzag line in here. That breaks it up into your metals and your nonmetals, metals being over here, your nonmetals being over here. And of course, you're going to have a shade of gray there along that line, and we think of those elements as having properties of both metals and nonmetals, and they are termed metalloids. Depending upon which reference, which textbook you use, what Google site you go to, they might list different metalloids because it's not just a black and white issue. So I'm not going to hold you responsible for knowing the exact metalloids. But let's just think about this basic rule, that they are found between the metals and the nonmetals. They have properties of both, and they have two sides on the zigzag line, but no sides on the outside edge of the table. If we try and stick with that, that kind of gives us an idea of which ones are the metalloids. Okay, so then we can also look at how our periodic table is broken down into a numbering system. We've got the IUPAC numbering system, and then we've also got a traditional numbering system. Both of these are very commonly used. The periodic table that we have in the classroom happens to have the IUPAC numbering system, which just says 1, 2, 3, etc., all the way over to 18. But we use some periodic tables lots of times that have a Roman numeral abbreviation. That's known as our traditional system. And what you should see from that is that these two groups and these 6 groups over here all have an A associated with those, whereas this drop-down group in here has a B associated with it. So the A is known as your representative elements or your main group elements, which we'll talk about later on. Okay, so now we can break down our groups. I'm not sure if I Okay, so I think I did not stress this. Let's go back to the fact that we're talking about groups. And these guys are also known as families. Those names are used interchangeably. And what you should see from this is that elements within the same group or within the same family have similar chemical properties. That's huge to understand. So that's going to explain in the upcoming units why things behave the way they do. And then if we break those groups down even further, we can see that we've got some specific groups that we should know the names of. And what I had asked people to do here in class was there is a PDF of your periodic table online if you guys want to go on there and you can annotate directly or just, it might be a helpful way to learn these. But that first group or column is known as the alkali metals. So you should know that name. So for example, hydrogen, lithium, sodium, potassium, all of those are considered alkali metals because they belong to that group. The next group is considered the alkaline earth metals, and that would just be also known as group 2. Okay, I did just have a question, and that question was, why is hydrogen considered an alkali metal? Actually, we know hydrogen is a gas, and oftentimes when we start thinking about the electron configuration, what's going on inside here, we're going to say, you know what, let's not put hydrogen over here. Let's think about hydrogen as being over here. So we're going to do that at times, but it does have some similar properties in the fact that all of these guys have one valence electron. You don't need to know this yet. They all have one electron that's in their outer energy level, meaning they all want to do the same thing with that one electron, meaning that it has similar properties to all of these other guys. Yeah, I know it's not really a metal in the way that we think of the properties of metals, but it does have similar properties because of that one electron that's in its outer energy level. Good question. Okay, so we said alkaline earth metals. Then we jump over here because we're still within that representative or main group. I'm skipping this little drop-down section. If I had gone here, I would just say, well, that's the boron group. Here, not very creative, but we're just going to call that the carbon group. Then we get to the nitrogen group. And then the next one is not the oxygen group, but it's known as the chalcogen group. It looks like chalcogen, but it's pronounced chalcogen. And then last couple, we've got the halogens. And then finally, we have the noble gases. And we'll learn some more things about the properties of these individual groups later on. Now that we've talked about our groups or families, we can now look at periods, which instead of being the vertical columns, we're looking at those horizontal rows. And these are easy to name because all you do is say period 1, 2, 3, 4, etc. They're just numbers showing which row it's in. So if I were to ask something like, what element is in the third period in the carbon group, everybody could say, oh, that is silicon. So then we get back to what we said about representative elements. These are the main group elements here and here. It's everything you see in blue. All of those are considered the main group elements. Has to do with their valence electrons, which we'll talk about later, but because of those are the ones, let's just say those are our main group elements. That's all we need to say right now. Representative or main group, same thing. As opposed to this drop-down section right here, which is considered the transition elements, also known as transition metals, same sort of thing. And then finally, if you look down in this little section, numerically we're coming along, we've got 56, then it goes to 71. That's kind of weird. And the reason being, this chunk of elements has been removed and put down here. So this is period 6. This is period 6, because after 56 comes 57. So that's still considered period 6. Here is period 7, here. And what we're going to do is we're saying that instead of just being in the transition metals, these are taken out from inside of the transition metals, so they are inner transition elements, also known as rare earths. I think we are we're done. We did it. Okay, bell rang. All's good.